I work in the field of biochemistry, where we are trying to understand the architecture and the interdependence of metabolic pathways. If you look at the biochemical textbook, you get the impression that everything is known. Every enzyme has one function and we know everything. However, the reality is different. It turns out that many metabolic enzymes have side activities, and the resulting side products can be toxic to cells. What we have recently found is that the enzyme phosphoglycolate phosphatase plays a key role in allowing the coexistence of glycolysis and the pentose phosphate pathway, two of the key metabolic pathways. Essentially, what we found is that two enzymes in glycolysis make side products that have toxic effects in a way that they inhibit the pentose phosphate pathway on the one hand and an upstream regulatory step in glycolysis. This means that if you don't eliminate those side products, metabolism eventually will come to a halt. Now, the existence of phosphoglycolate phosphatase allows our cells to eliminate the side product and allows the coexistence of glycolysis and the pentose phosphate pathway. If you look in the mouse, you inactivate the gene in mouse, it's embryonically lethal, which means that we have found an enzyme that doesn't serve a canonical metabolic function, but it's key for the coexistence of major metabolic pathways. And we believe that other enzymes exist that don't serve core metabolic functions, but that might serve to eliminate side products that otherwise make a mess in cellular metabolism. To understand or to discover novel metabolic functions, we basically pursue two complementary approaches. On the one hand, we engineer cell lines by mutating the genes coding for metabolic enzymes. We then analyze the metabolic changes using state-of-the-art mass spectrometry. This gives us a global overview what happens if you don't have the enzyme that we are studying. However, in parallel, we purify this enzyme and analyze what happens if we incubate these enzymes with purified substrates. And so taken together, the two complementary approaches allow us to understand on a molecular level the action of the enzyme and how it is embedded in known or unknown metabolic pathways.